The first sheet, we were all good, yeah? All pretty confident. It was making sense that if I've got 3 fifths and add 1 fifth, I end up with
4/5.
4 fifths. Do you remember when I gave you those circles? And we were talking about comparing fractions together and different size pieces of the circles. It did make sense. So we were writing equivalent fractions, but we're going to get into that. But if I have 3 fifths, who can tell me how many pieces the circle would have been split into then? Yeah? 5 pieces, yeah? Have you? No? Circle would have been split into 5 pieces. So I've got, can you just visualize how big would those pieces be? Quite big or quite small?
Big.
Big. A circle split into 5 pieces.
Medium size.
Medium size? Yeah. Give that. Yeah, I like what Giovanni's doing. He's cutting them up. Circle split into 5. So if I've got 3 of them and then I've got 1 of them, it makes sense to put them together. Do I have a whole circle or not, Dave?
No. Oh, fine.
Why did Jack say no?
Also, wait, you said it
So
like,
if I have 3 pieces out of 5 and I add another one, I end up with 4. Would I have an entire circle?
5, 5.
Good. I would need 5 pieces to have the whole one. So this whole sheet was all about that, yeah? Nothing particularly difficult. So we get to 6/25. If I split a circle up into that many pieces, Justin, what do you say about the sizes? Would they be big pieces or small pieces? Looking at this question. Because, yeah, how many pieces? How many pieces would the circle have been split up into in total? It's not. Austin, can you help me out? So for this question, we're looking at those circles have been split up into pieces. How many pieces would those circles have been split into, Austin?
25.
25. That's this number, yeah? And then I have 6 of those pieces, and I add 11 of them. How many would I have in total? 17. I have 17 of those 25 pieces. Yeah? Yeah. The next sheet is more of the same. Nothing different. Is there anything different about this sheet? What, Harry? Have to simplify. Okay. So, for instance, if needed, let's do number 14, Riley. 23 fiftieths plus 17 fiftieths. What does it give me? Fifty is the denominator, and 40. And what does that simplify to? Yeah. We could do a bigger one though. 10. Good. So if I divide by 10, top and bottom I get. Good. Alright. So those ones are simplifiable on that sheet. I think it was this sheet where I started noticing some issues. So I just wanted to check. Now, so the third sheet. Now, one thing I'm going to do is I'm going to say to you, I don't know whether you spotted, but on a few people's sheets, I started drawing a box around the question and then a box around this because it's the same question, but it has been changed before we write the answer. Okay, so the change here is that the denominators are now not the same. So we can't do what, Austin?
You can't. You won't be simple. And it won't be.
So what can't we do that we were doing before? We can't just add the 1 and the 3. Now, what I saw people doing, because they just rattled through what they were doing before, so trouble with smartwatches, isn't it? That's why we ban them. Phones thing. That's exactly the reason. Some people were doing 1 plus 3 makes the 4, and then doing 4 plus 3 makes the 7. But that's not what we're asking.
Do you still put the one there?
Don't. No. Jack, would you like to explain?
Because it's 1/3 or 1/3 of 6, which is 2. So you're actually adding 2 6.
Okay, so we can't add different size pieces, can we? Hope you haven't made these mistakes, because if you don't spot, you won't realise, will you? We can't add thirds and sixes. 6. Why can't we do that, Giovanni? Why can't we add thirds and 6 like together in the circle? What was the problem with that? No idea? Maybe anyone wants to tell us why can't I add pieces together if I've got thirds and sixths? Well, not the same number, therefore those pieces are not the same size. Yeah? So these pieces here, this one piece is bigger, no? Than these ones. So what do I need to do? I need to chop these ones up. So 1/3, Jack already told us, same as
6.
2 6. Now they're the same. So how did I get that? Austin?
Multiply the
Yeah. So I can multiply that by
2.
2 to get the 6. Now can I add those together? Yes, I can now add them until I get 5 6. So on that sheet, that's what we're looking for. So we've got to change one of the fractions. Have you? Yes, okay. Yeah. Right in front of everyone's eyelids. Javi would like us to do 2. Who would like to talk me through the 2? Yeah. Yeah. So 4 can be multiplied by 3, having to get 12. Yeah. So Mia, carry on. By 3. It's got to be by the same number. So 1 times 3 gives me 3. Now I can add them together and I get 7. Okay. People okay with that one? If you can, I would always like you to try. But before you do, can I just move us just quickly to this one? Can you all get to this sheet, please?
Which sheet is that?
Go through, just turn the pages like. If you start at the front and then just flip a few pages, you'll get to this one.
Don't think I did.
That's right, some people might not be to it, but I want to go through it now.
Oh,
I've seen a couple of people. So let's have a quick look at this one just so that it gives people a chance to go through it. Now, is everyone with me on this sheet now? Okay. So the first one, I've pretty much got the explanation. It does take a little bit of looking at, right, to figure out what they've done. So I will highlight for you that the 7 quarters, well, that's still there. All right, so the 7 quarters is still there. And the 5/3 is still there. But what we've done is multiplied by 3, this one, and multiplied by 4 on that one. Okay, that's the question. Good question. Why? Why have we multiplied this one by 3 and this one by 4? Justin?
Oh, I noticed that the denominator for 7 over 4 is 4, and it's 5 over 3 was multiplied by 4.
Yeah.
5 over 3, the denominator is 3, so and it's
Yeah, go on, keep going. You're on the right track.
oh yeah, 5 over 3, the denominator is 3, and 7 over 4. 7 over 4 is multiplied by 3.
Yeah?
Yeah, the denominator is like multiple,
Yeah.
something like that.
So we've taken this number here and multiplied this one by it, yeah? And then we've taken this number here and multiplied by that one, yeah? Why did we do that still? I still don't have an answer of why. Anyone know? Amara? Well, why we've done that is because if I multiply those two together, obviously it's the same thing now, isn't it? Multiplying both, and I end up with 12 and 12, which is the same denominator now. So I've gone from having a question with two different denominators to having a question with the same denominator, right? Are you with me? Yeah? So what do I do now? Now we can plus the 21 and the 20 and we get
41, 20.
41 twelfths. So on this sheet, it's about rewriting both. Okay? I just wanted to get, because I know some people were at that stage and they were finding this sheet a little bit confusing.
Can you keep that up?
I will keep that up. Alright? Okay, all good? I think a couple of people that I didn't manage to get to probably need to go back to the other sheet because you were doing what I said and just adding and adding and adding even when the denominators were the same. So just check that you haven't done that.